our next session, which is the keynote discussion with Tony Ephremides. Let me thank very much Tony for accepting to be with us and for preparing a very nice presentation that you can find on the YouTube channel on a very interesting topic, which is where the title of his keynote is Freshness of Information. Many of you might know this under the name Age of Information, which has become very popular in conferences in these last years. But before coming to that, let me read the biography of Tony, because I'm sure you all know about Tony, but his biography is quite impressive. So let me just read that. Anthony Ephremides is an IEEE Light Fellow. He received his bachelor degree from the National Technical University of Athens and the Master of Science and PhD from Princeton University, all in electrical engineering. He has been at the University of Maryland since 1971 and currently holds a joint appointment as professor in the Electrical Engineering Department and the Institute of System Research, of which he is a founding member. He is co-founder of the NASA Center for Commercial Development of Space on Hybrid and Satellite Communication Networks, established in 1991 at Maryland as an offshoot of the ISR. He served as co-director of that center from 1991 to 1994. He also holds the endowed Chintzia Kim Eminent Chair of Information Technology and has been designated as Distinguished University Professor at the University of Maryland. He was a visiting professor in 1978 at the National Technical University of Athens in Greece, and in 1979 at the Electrical Engineering and Computer Science Department of the University of California, Berkeley, and in Riyadh, France, during 85-86. And at Riyadh in France. During 85-86, he was on leave at MIT and ATH in Zurich, Switzerland. He was the general chairman of the 86 Conference on Decision and Control in Athens. He was the general chairman of the International Symposium of Information Theory in 91 and 2011. He organized 2 workshops on information theory in 84 and 99. He was the technical co-chair of Infocom in 99 and of the IEEE International Symposium Information Theory in 2000. He has also been the director of the Fairchild Scholars and Doctoral Fellows Program, an academic and research partnership program in satellite communications between Fairchild Industry and the University of Maryland. He won the Donald Fink Prize Paper Award in 92 and was the first recipient of the SIGMOBILE Award of the ACM for contribution to wireless communication in 97. He received the 2000 Fred Ellerichs Milcom Best Paper Award, the IEEE Third Millennium Medal, the 2000 Outstanding System Engineering Faculty Award from the Institute for System Research, and the Kirwan Faculty Research and Scholarship Prize from the University of Maryland in 2001. He has been the president of the Information Theory Society of the IEEE in 87 and served on its board of governors almost continuously from 81 until present. He was elected to the board of governors for the board of directors of IEEE in 89 and 90, and he received the 2006 Aaron Wiener Award for Exceptional Service and Leadership to the IEEE Information Theory Society. Dr. Ephremides has authored or co-authored over 200 technical journal papers and 400 technical conference presentations. He has contributed chapters to several books, edited numerous special issues of scientific journals. He won awards from the Maryland Office of Technology, and for commercialization of products and ideas stemming from his research. He has served on the editorial boards of the IEEE Transaction Automatic Control, IEEE Transaction Information Theory, Journal of Wireless Network, International Journal of Satellite Communication. He is the editor-in-chief of the Journal of Communication and Networks since 2016. He has supervised over 40 PhD students, and he is the founder and president of Pontos Inc., a Maryland company that provides technical consulting services since 1980. Dr. Ephremides' interests are in the areas of communication theory, communication systems and network, queuing systems, signal processing, and satellite communication. His research has been continuous support since 1971 by NSF, NASA, ONR, ARL, NRL, NSA, and industry. Quite a remarkable curriculum and quite an interesting topic for his keynote. And this topic of age of information is extremely interesting. The only thing that I didn't quite understand, Tony, is how comes that information doesn't become more and more valuable as age progresses? How is that?
I'll try to answer. So, do I have the floor now?
Yeah, sure. The floor is yours.
Thank you very much, Marco. Thank you. I want to steal one line from Fred Jelinek. I don't know how many of you remember Fred. He was an information theorist, and he was initially at Cornell University, then at IBM, then at Johns Hopkins. Anyway, he also had a great sense of humor, and I remember after a very laudatory introduction before a talk he was going to give, which is like yours, Marco, he said, "Thank you, but I'm not dead yet." Anyway, so about the question you asked, information, the value of information. You see, inadvertently perhaps you touched on a crucial aspect of the notion. It has nothing to do with meaning. So yes, maybe old information that survives the test of time, or whatever you want to call it, take the Bible, Shakespeare's works, and so on, that is a function of the content and its meaning, and of course then the value is judged differently. In our field, I guess, we get this amoral view of looking at information as flows of data, and as we try to assign notion of meaning or value, we try to look at attributes that are within the data science, let's call it, in a very broad sense that includes computer science, signal processing, information theory, and everything. And therefore, all the information need not that it is not, but need not become less important. In fact, there is one little line in my talk that I didn't elaborate very much, but if the signal, the process that you're sampling and you're sending updates to a destination, is not Markovian, then it is entirely possible that your ability to predict its future may be better if you have several older values of the signal than fewer very recent values of the signal. So yeah, old information is not necessarily bad.
Okay, let me remember people in the audience that they should write a line on the chat in order to submit their questions, and then we'll proceed in turns. Meanwhile, Falco, Renato, you have questions for Tony?
So if Paolo doesn't switch on the phone faster than me, I can take. So I have a follow-up on what you just said, Tony. If the system is not Markovian, okay, then information, all information might be useful. Clearly, Markovianity is an approximation of life. Right? It's the easiest way to give some memory to our models, nothing more than that. What is your perception around this? Is the Markovianity of the word that we have been using as model reasonable, possibly also in light of the advances of machine learning, these things that probably have a deeper memory than Markovian? We are finding out Markovian modeling too bad of an approximation. Marco, you should switch off your mic when we talk, because I have a lot of echoing on your mic.
Yeah, so Renato, your question is about the Markovian assumption, right? And its meaning. It is motivated, you know, how we use models in everything. There have to be two, not sufficient, but necessary conditions they must have. Otherwise, they're not good models. Those conditions are, number one, mathematical tractability, and number two, physical motivation. I think, like Gaussian, take the Gaussian assumption that we make for noise, or the Poisson assumption for traffic data and so on. Mathematically, they've proven to have wonderful properties that facilitate analysis and our ability to predict. Now, there are also physical justifications for them. The Gaussian assumption, even though everybody knows, right? The Gaussian assumption for a signal means that with small but non-vanishing probability, it can have arbitrarily large values, which we know is not the case. But the central limit theorem is the justification for the reasonableness of the Gaussian assumption. Many phenomena are superpositions of many independent components, which we know converge to a Gaussian-like distribution. So we make such allowances. I want to mention also another related, before I come directly to the Markovianness that you asked about, another important, very important talk that David Slepian, one of the icons of information theory, had given. It was the second Shannon lecture in the history of Shannon lectures, which are the highest distinction one can obtain in the information theory field. The first one was 1973 by Shannon himself. So 1974 was David Slepian, who gave a talk on bandwidth. And he said that, you know, to me at that time, I was a starting assistant professor, it had never occurred to me that if you have a process that's band limited means doesn't have frequency content beyond a finite range of values, it cannot be time limited. So it must last forever. And if it is time limited, it cannot possibly be band limited. So the model we're using is faulty, but it serves many purposes. We tacitly admit it and use it, but it's imperfect. And another one for electrical engineers might be interesting. You know, I don't know how many in the audience have electrical engineering background, and by that I mean classical electrical engineering, where you deal with electrical components like capacitors and resistors and so on. So if you take two capacitors and each one is charged to a different voltage. So you have one capacitor of capacity C1 charged to a voltage V1, and therefore it has on it a electric charge of value Q1. And you have another capacitor which has C2 capacitance, it has V2 voltage and the corresponding Q2 amount of charge on it. And you take them now and you connect them in parallel with a switch. You throw a switch. What will happen is both capacitors will come to the same voltage. So there will be a movement of electric charge from one to the other. So what is preserved? Physics tells us that there is preservation of energy. You cannot create or lose energy. So the energy value is 1/2 capacitance times voltage squared. Also, physics tells us that you cannot lose electric charge. Electric charge, Q, is C times V, capacitance times the voltage. Both cannot be satisfied simultaneously. If you want to find the new value of the voltage that the two capacitors that were now connected in parallel have, if you choose to work with preservation of charge, you will find a different value. And if you choose to work with preservation of energy, you will find a different value. So this is a classic question that one poses in sophomore classes of circuits in electrical engineering. And the smart student will say, hey, I know what will happen. Energy will not, protons and electrons cannot escape. So charge will have to be preserved, but energy won't be preserved because when we throw the switch, there will be a spark. If one capacitor is at a huge voltage and the other is at a very small voltage, you connect them together and there will be a spark dissipating energy. And of course, then the answer is, but models do not spark. There is no provision in the discussion of ideal capacitors that there is sparks involved when you connect them. So, all this, to make the story short, is that models are imperfect. They serve purposes which are grounded to some physical reality and also have mathematical virtues. Markovianness does have some physical support to it because, remember, one definition of Markovianness is that given the present, statistically past and future are independent, which for many phenomena is reasonable. Take the motion of a body in space. If I provide you with the current value of position, velocity, and acceleration, then its future trajectory does not depend how it got where it got. So now, in the cases where we use the Markovianness, I agree with you that sometimes it's a simplification and it is simply not valid. So, a long answer to an important question.
Thanks a lot, Tony. I see there
We
is
have a question by Edmundo.
Hi, Tony. Can you guys hear me? Because I had problems with my network during this session. Is it okay now?
Yeah.
Yeah, we hear you and see you.
Yeah. Okay. Hi, Tony. Very nice, very interesting talk. And I'd like to bind together with the talk by Jim about this. Once you get the delay, moving to ISDN, once you get the delay of information, what can you say something about that? It seems that we need this both distributed, fast information, and also it can tolerate something. How? I would like you to, if possible, to elaborate more on the SDN part and the delay to get information.
Yeah, with the age of information, one must realize that it has not really entered yet the field of networking proper. The whole idea of age, and there have been, and I will elaborate with that, there have been little extensions and excursions away from the source channel destination model, but that's how it started. And you talk about a very simplified model. There is one signal ongoing, there is a process ongoing. The stock market is developing, and I am a user who wants to know most recent value of a stock. And the one who observes the evolution of the price has the responsibility to keep me up to date with the fresh information. Nothing to do with networking yet. So one key thing that many people still confuse age with delay. Delay is a component of age, but another crucial and even more important, perhaps, aspect of age is the sampling instance, the sampling, not just the sampling rate, but the exact times that you decide to sample. And this is what created this developed interest in the topic, because it introduced a new notion that people had not connected. You know, typically you say every tick of the clock I take a sample and I transmit. If you have the choice of deciding when to take a sample to transmit, then the whole picture of the utility, the value of that piece of information to the destination acquires this notion of how old it is in terms of age. And the age is coupled to the time it took to get there, delay, and also to how frequently you sample its value as it develops. So the whole field has centered on that model, although there have been, as I was saying before, lots of studies where people say, okay, now let's embed this in a network environment. So we have obsolete packets. That was one of the very first observations that people made. Said, okay, you're sending the price of the stock over a network now, not a dedicated channel. Now that packet of information will probably follow a path where it will go through intermediate nodes and experience processing and other delays. And maybe by the time it arrives, a more recent sample that was sent has overtaken it arrived before. So there were observations that acquired the networking dimension. Unfortunately, the networking community hasn't yet, let's say, spent enough effort to think about age and contribute from the networking viewpoint to the field. There have been a lot of interest lately by control theorists of all disciplines, because in control systems you have a crucial dependence on how old the information is. Sensors make observations, they send them to a controller, and the controller uses these observations to instruct an actuator about an action, control action to take. So how old these measurements are is very important. And if you have multiple sensors, and that's where there is a potential connection to networking, then the control people look at it differently, and they introduce their own methodology and mindset, but they have seen the value of age. In signal processing, also, people have seen the importance of this sampling process. Let me tell you one observation that I have seen for many papers that are sent, for example, to Infocom by networking people, where it is clear that they confuse age with delay, because you find papers about unmanned vehicles and how they're, that's where it's very important, right? In autonomous vehicles, when you want to avoid a collision, the position, velocity, and so on of a neighboring vehicle is very important. If it is old, it doesn't do you much good. But they make the assumption that contradicts the whole notion of age, that these samples are taken every so many nanoseconds, milliseconds, microseconds. So it's periodic sampling. Once it's periodic sampling, then there is delay. That's it. The age, as connected to both delay and sampling, disappears. So in order to make that distinction, it's important to see that the only factor that makes a piece of information obsolete somewhere is delay, then we know how to deal with that. I mean, we've been dealing with that for a long time. But if you want to make that additional distinction that no, it's not just delay, it is freshness. So it is the difference between the current time and the timestamp of generation of the most recently received sample. That's a very different notion. And in networking, I think we have a bigger mountain to climb to embed this notion in a meaningful way to address your question of how it relates to network architectures, management. We haven't gotten that far at all. And so I don't think I would venture to even provide a judgment or conjecture or something about how freshness and age, how they should be taken into account in network design and operation. I think it's very important, but we need to cover a lot of ground, and I hope that we will be seeing more activity by networking researchers in that direction. You know, there is this Age of Information workshop that will be happening just before Infocom, this time virtually, early in July. It took place twice already, just before Infocom, exactly in order to expose the concept of age to people who work more, have more background in the networking field. So hopefully we will be seeing more involvement, but it's a very open and fertile ground there. So we don't have an easy answer to provide on this.
Yes, thank you very much. Very nice.
Tony, one question I have is, does the definition of age of information that you provided in your presentation fit all problems? Because I see it is very well matched to control problems like the ones you mentioned, but that is a very specific case with interesting applications, like, for example, if you have to control autonomous vehicles or things like those, where you really need to worry about the difference between the information you have and what is the present state of the system that you are trying to control. But there are other contexts where the value of information that is provided to you by an arriving packet does not only depend on what is the difference between the generation time of the information you have and the current time.
Yes, yeah. Go ahead.
Should we not consider alternative definitions of the value of information, which is essentially dependent on the type of problems you are trying to solve?
Absolutely, yes. And in fact, this has been a natural branching out of the original investigation of the concept of age, because we realize that age, although in the beginning it sounds reasonable and attractive, right? You want to know the freshest information about the value of a stock, okay, or the position of a vehicle. There are early thoughts that were saying, wait a minute, if the signal doesn't change very fast, the age is unimportant, right? Or it has a very diminished importance. In the extreme, if it is constant, if I give you its current value, it will be good forever. So age itself, in its original definition, starts very quickly showing limitations of its value. And this is why there have been subsequent attempts to invent other measures of value that to some degree may be related to freshness, but even completely out of the freshness concept. Especially in the US DoD, Department of Defense, the notion of value of information has been a term that's been kicked around for decades without convergence, because the military have a mission and they have a model in their minds about what is that constitutes valuable information against that mission. So they say, can we capture that value in a technical way, some measurement of an attribute? And they have not managed to do that because there is great variability depending on the objective. So, as we know that people who are very old, have a high age, but are very robust and athletic, they have effective age, which is much younger, and vice versa. You have young people who have aged prematurely. The notion of effective age is something that was thrown on the table very early on, and it has not converged yet because people haven't found good measures of how would we say, okay, this piece of information may be so many milliseconds old, but it's so many milliseconds effectively old. The notion of age of incorrect information that I discussed briefly in my talk is one such attempt to expand the definition of a measure. But let me get back to anything that has to do about freshness and age and closer to your question. What is the criterion to make somebody associate freshness and age with value? If you think about it, the only one that anybody so far has been able to suggest is the quality of your prediction for its future. That is, if I'm interested in the position of the vehicle or the value of a stock, I want to know it because I want to predict what it will be. What is the current value? Should I sell or not the stock? Or will it go up or down in a few minutes? And the position of a vehicle or a tracked missile or whatever, again, it is the ability to predict. And age is a very good surrogate concept for prediction error. So this is where the limitation of age is not a panacea for everything. It is only good provided it fits a certain framework that people agree that, I'm receiving information about the evolution of a signal, of a process, and I really want to know its current or predict its future value. Then the fresher the information, the better. But again, there are caveats, and I did mention in my talk a little bit of that, right? I said, is it better to have correct, fresh old information, or not so perfectly correct recent information? That's not an easy trade-off to analyze from the perspective of how well can I predict its future value. Sometimes, if I have more recent measurements that have errors, I might be able to predict better than if I have a very old, accurate value of the signal. So, yes, it's by no means a panacea, and the quest for measures of value is still going on, and it's clearly connected to the variety of objectives that we have. There won't be any single measure for how valuable a piece of information is.
We have Farouk.
Yeah, just actually, it's not a mainstream question, but I was wondering, did you try to look at the problem of the fake news, and how are there some kind of approaches or ways or methods to tackle this kind of problems? Because it's, in a way, it's related to information, abundance of information, sources and origins of information. So maybe just a general question, just to see your thought about fake news. It's a very hot topic. Thank you.
Yeah, let me see if I understand. I'm not sure I understood your question. You say something about the role of the sources of the information. Is that what you're?
I'm talking about the fake news. The fake news that now we have on the network.
Yes.
fake news. How to tackle this kind of problem? It's a major problem. And how does the theory that you, with freshness and time-related information, how can it help in handling this kind of major issue in society?
Yeah, that's a very good question. Now, notice that, of course, the fakeness of a piece of news is connected to the content, which in communication systems we are blind to, right? We do not try to say these bits are useless because they are phony. But the truth of the matter is that we could have such contexts. And it's interesting that you mention it because I have started a collaboration with, I don't know how many of you know Wolfgang Kellerler from Technical University of Munich. He and a student of his, Onur, I just remember his first name, Onur, because his last name didn't register. It came and visited me in Maryland in late January and had to leave. He was going to spend the whole semester, but he had to leave with one of the last flights out of Washington for Munich around mid-March. Anyway, the topic we are looking at there, and we continue remotely the collaboration, is suppose you have two sensors. I mean, people always say we have n sensors, where n is huge. I like toy problems where I can condense the essence of the problem into manageable size. And so, say we have two sensors and they are measuring the same or different aspects of one signal. Okay, so the signal is two-dimensional or maybe six-dimensional, velocity and position, and one measures position, the other measures velocity. And I know, as the receiver of this information from the two sensors, that one of those is reliable. That is, it is correct, timely, in any way, even if it has incurred a few bit errors in transmission or some delay in transmission, it is not fake. The other one, I don't trust, and I don't know what it is. It could be a malevolent sensor which has been compromised and is trying to derail my prediction of the signal, which is my objective. So there, automatically, what do you get? You get game theoretic formulation. You have one malevolent user who wants to derail what you want to do, which is to estimate correctly, and this opponent, this player, who is your, as in game theory, we have the zero-sum games where one player wants to maximize something and the other player wants to minimize. In this case, it can be more complex because we can assume that this other player has a variety of motives. And so this is a quantitative effort to capture this notion of fake news, which I think it would be very, very important to be able to develop a variety of quantitative approaches to it, because it has more dimensions than just that the information is not the truth, that it's a lie. And it has subtle aspects also. It may be true, but as they said, the truth, the whole truth, and nothing but the truth, right? So it may be true, but not the whole truth, or it has some true and some non-true components. So yeah, I appreciate your bringing up this point, because it is something that it has arisen naturally the more you think about these problems. And as I said, we have just started the kind of investigating a little bit of that.
Thank you.
Tony, you mentioned the impact of predictions, and that in this period brings to our mind the possibilities brought by machine learning, AI, and so on. Is there any direction in analyzing the interplay between age of information and AI-related topics?
Yes, indeed. And there have been a few papers already written on that. I would like to open a parenthesis. Anybody who wants to probe more this field, visiting the website of Yin-Sun, Yinsun, is a very talented researcher who is now at Auburn University in Alabama, and I work jointly with him. He maintains a website with all the papers that have been written so far on the topic. This is an amazing resource for any field that I know. I don't know that there are such repositories that are complete. Okay, he captures every paper that gets added, and it's worth visiting and see how he has it organized. Anyway, so there have been papers written on machine learning, and there have been different approaches. Here is, for example, one. The analysis of the age of information in a typical context among the very first ones was, okay, I take my samples and I put them through a delay-inducing medium. It used to be like an MM1 queuing system, for ease of analysis. And then the effect of the sampling rate or instance and the delay that the system introduces produces the resulting age that I analyze, and I try to optimize its value, minimize the average value by choosing sampling or a parameter of the model that I have, or the MM1, for example. And so the machine learning approach has, in this limited context, taken the view that, okay, suppose I do not know anything about the delay-inducing medium. So I know just that there will be delays, and I can measure experimentally. I can see what is the effect on the age of the receiver of something I send right now through this box. So how can I optimize my sampling rate when I do not know the model, the parameters of that delay-inducing medium? One early approach was to say, no, I know something. I still know it's MM1, but I don't know its service rate. I don't know the mu. So then, one of the early machine learning views is, I learn the value of mu by repeated observation. Better yet, you go then to the next stage where you say, I don't even know what it is, not MM1, it's completely unknown. So how can I still try to do a good solution to the sampling pattern to have a maybe not optimal minimum age, but reduced age? And there are, again, some of the learning techniques that are used and developed in the machine learning community that some authors have used. So there is definitely room for using machine learning methodologies in dealing with age, and it has to do, as with almost anything that machine learning is applied to, with the degree of knowledge that you have about a complex system. And if you don't have enough, there are all these intelligent techniques of learning, adapting, and optimizing. So there is, again, already 2-3 years ago, the first papers appeared, and they seem to be picking up momentum.
Okay, do we have more questions from the audience?
Let me make one closing comment that I meant to make even earlier. I didn't have a chance to express also my, first of all, thanks and appreciation for everything you have done with the conference and how nicely you adapted it to the virtual environment. And also pay tribute once again to our dear friend Mario, with whom I had also a close personal interaction and relationship. And it pains me that we don't have the chance to have him with us now. So we'll always remember Mario.
Thanks, Tony. Yes, this conference was really meant to honor Mario's memory. That is why we had chosen Arona as a location. But we will not forget to go to Arona in one of the next editions. Next year is risky because we don't know if we will be COVID-free next year. So next year maybe we do something different. But Arona is surely on the list, and when everything is over, we will volunteer again to organize a live event in Arona, and it will be a big pleasure to walk in Mario's steps and be there all together. So thank you very much. I really appreciate you being here with us, you sharing this very interesting presentation on such a hot topic, and I'm sure we will learn from it, and it's a problem on which we should start looking more. So thank you very much. I think this has been very beneficial also for the many younger people in the audience who probably are not yet familiar with these concepts, and your presentation will help them familiarize with it.
Right.
So thanks a lot. Thanks for being us. Virtual applause.